When conducting experiments, it's always good to be able to calculate your percent error. So this DeBacco University video is going to walk you through the process and steps to go about doing just that. Alright, so calculating percent error is not that difficult. You're looking at the estimated value, the real value, a simple subtraction, a division, multiplication by 100 to get to the percent, and therefore you can go through and see how accurate your results were. So keep in mind that this equation is kind of the key one here. You're going to get the experimental data point. You're going to subtract it from the actual number. And then the key part is you're going to take that difference, divide it by the actual, multiply it by 100 to get your percent error. Now what is percent error? It's used to determine the inaccuracy in percentages of an estimated value compared to the actual value. This determines the accuracy of your measurements as well as it quantifies the difference between the experimental value and also the true value. So the experimental value is what you might conduct in lab, the results you might get, and the actual might be the real result, or what was actually based on 100% yield, what the result should have been. So the formula breakdown, here we're looking at the estimated value is the measured value, and again that occurs during the experiment, and the true value is the actual or exact value that should have been achieved. You can see here we've got the same basic process here for calculation. Again, not that difficult, but something you do need to know that you're dividing by the true value, taking your measured minus the true and divided by the true times 100. Since this is an important problem, important process, I should say, let's go through some problem sets. So in problem 1, student 1 calculates from an experiment 22.7 grams of sodium chloride recovered from a solution. However, only 21.8 grams of sodium chloride were present in the solution when it was actually made. So that's that's the known value. What's the percent error for the student? We also have here the actual value of an absorption of carbon is 0.135. The student calculated the absorption as 0.235. What's the percent error? So you might want to pause the video here and try to do some quick calculations there to see what answers you get before I progress to the next slide. All right, so looking here at the answers to these, how would we go about that? Well, the first one would be 4.13, and the second one is 74.1. You take your difference times 100 divided by the actual. So again, to 22.7 minus the 21.8. Remember that the given, or the actual, was 21.8 grams times, subtract those two, divide it by the 21.8, multiply it by 100 to get your percent error. The same thing here, we get our difference. Hit the student's value and the actual value, take the difference, subtract by the actual or given or known value, and then we multiply by 100, and in this case we get 74.1 as the percent error. If you're confident in these, let's do a couple more. Problem set number 2. Adding this a little bit more here, we're looking at temperature as well as grams. So boiling point of water is 100 degrees Celsius. During an experiment, water came to a boil at 97 degrees Celsius, according to the thermometer that was being used. What's the percent error of that thermometer? An experiment was conducted to find the mass of 1 mole of carbon atoms. The result of the experiment showed that 1 mole of carbon atoms had a mass of 15.78. The actual value is 16.00 grams. What's the percent error here? So I'm not going to give you the full breakdown, but again, you might want to just pause the video quick here, or maybe refer back to the problem set number 1 to see how we've calculated those, and hopefully get the right answers here. All right, I'm going to go through and review the right answers, and the first one is 3.0%, and the other one was 1.4%. If you didn't get that, go back to some of the previous ones, look back at your steps, and you should be hopefully on your way to easily being able to calculate percent error.